The coping commands in Multisteel are completely flexible. These members can be offset, they can come in at any angle, any plane. We can also introduce another member in between these, and we can cope that member back to these horizontals and the jacket leg, so we get a complete connection. So really there's no limit to the capability of the routines that calculate these end profiles. I've added some additional steel work to the bottom level of our structure here. We're going to focus on one particular piece of steel just to illustrate the basics of how Multisteel works for cutting back members and for creating the fabrication details. We've got a fairly complex connection here and a simple tube-to-tube connection at the other end. First thing we're going to do is give a mark number or a name to this particular piece of steel. That's important from the fabrication point of view, and it will annotate the detailed information with the mark number, which is what we want anyway. Let's go to Edit Steel. Let's click on the member, and we just highlight name. We're going to give it an item number, and I'm going to call it B123, and I'm going to say apply, and then that will be applied to the member. Okay, so if we now queried that member, if we go to our query command or inquiry, it will actually show its member name along with all the other properties of that piece of steel. Okay, so we know it now has a mark number. We're now going to use the coping commands to cut it back. We're going to go to the coping dialog. We're working in polymesh mode, and we're actually going to select cutting sketch, wraparound template, and table of data coordinates as well. So click on OK, select the member. We now need to select all of the pieces of steel that it connects into. So we've got one there, we've got three at this end. And Multisteel will work out all the geometry for us. It actually produces, if you press F2 at this stage, it actually produces a summary of all the principal geometry, which can be quite helpful as well. Okay, press F2 to go back to graphics, and we'll place our data over here. It's already created the wraparound template. We're going to create a data of cutback coordinates, and we're now going to insert our bracing sketch as well. Okay, so let's go to Plan View and have a closer look at our data. This is our coping information. This is our mark number. And let's just sort out our dimensions a little bit. Okay. So from that would actually give us our wraparound information. This is a table of coordinates at each increment around the circumference, and these are our values from a datum point, giving us a complete table breakdown. That information also can be exported to a data file for CNC linking to profiling machinery. This is our bracing sketch. So we get a full summary of all our principal dimensions on that as well. And here we can see the double cut. In fact, there's three cuts at that end coming into our complex connection, and this is the simple cut at the other end. So that's a typical example, just taking one particular member. I'm not going to do more than that because they all follow the same pattern basically. And within the 3D model we can do all of our cutbacks, our copings, and generate our fabrication details straight off the model. We could also do that to a certain degree on the 2D drawings as well, and some connections will lend themselves to that kind of approach. The only thing is, in this model we've got a three-dimensional connection problem here because of the sloping can, which is out of plane with the other members. But these cross-bracing members, they could all be coped back on the 2D drawings. So sometimes there's a mixture of using the two approaches. Just to mention again the set view command. If we go to set view, we've got all of our plan levels now. So if we go right down to base level, in fact we just come up a meter off base level, it will show us the level that we've just been working on. So we're actually isolating that from our frame. Come up a level from that, and it just shows the edge members. Now we're just working up the structure. Water level. Let's go to sloping view. Here we have 4 sloping views, and it will show us the complete view. That's actually as the 2D drawing. The general arrangement drawing will be generated. And they're all the same, in fact, because we're dealing with a symmetrical structure here. Back to ISO, set our UCS back to world. We haven't done all the cutbacks yet, but if we wanted a quick estimate of steel weight and material, we can go to material summary, put a window around our structure, go to cutting list. So we can get various reports. We can get a cutting list, we can get totals. We've got total length and total weight down here and total surface area. We go back to cutting list. This is a breakdown by size. We can add that onto the drawing, or we can export it to an Excel file and then use the data for some other purpose, such as ordering materials or costing purposes. Let's cancel that. We might also want to know the centre of gravity of our structure. Let's come down to, this is actually the second 3D menu, flyout. We just go to C of G, put a window around our structure, and it'll calculate our C of G. The cross indicates the physical position of the centre of gravity, and these are the X, Y, and Z coordinates. Total quantity of steel members and total tonnage, which is about 2,000 tons. We'll just OK that. So that completes this stage.